Good day. This is lesson 8B entitled Tangent Plane and Normal Vector to Level Surface and Lagrange Multiplier. Let me first discuss to you tangent plane and normal vector to level surface. We have here the following definition: tangent planes and normal vectors to level surface. It says here the tangent plane at the point p sub 0, x sub 0, y sub 0 on the level surface f of x, y, z equals c of a differentiable function f is the plane through p sub o normal to gradient f evaluated at p sub 0. The normal line of the surface at p sub 0 is the line through p sub 0 parallel to gradient f evaluated at p sub 0. So this is, for example, the given curve or surface f of x, y, z equals c. So as we can see, we have here a tangent plane colored brown, which is, or rather a plane which is tangent to the given surface. And we have here the point P sub O on the surface and also on the plane. So with that, we now have the normal vector represented by gradient f. And we are concerned with defining the equation of this tangent plane and also the normal line, which is parallel to this gradient f. Let's have the following formula. So we have here equation of tangent plane and normal line to a surface. For the equation of tangent plane, so we have here the partial derivative of the given function with respect to x evaluated at the given point p sub 0 multiplied by x minus x sub 0 plus the partial derivative of the given function with respect to y evaluated at p sub 0 multiplied by y minus y sub 0 plus the partial derivative of the given function f with respect to z evaluated at p sub 0 multiplied by z minus z sub 0 equals 0. So this is the equation of the tangent plane to the surface f of x, y, z equals c at the given point p sub 0 with coordinates x sub 0, y sub 0, and z sub 0. For the equation of the normal line to the surface, that is, we have here the parametric equation given as x equals x sub 0 plus the partial derivative of the given function f with respect to x evaluated at p sub 0 times t, then y equals y sub 0 plus the partial derivative of the given function with respect to y evaluated at p sub 0 times t, then we have z equals z sub 0 plus the partial derivative of the given function with respect to z evaluated at the given point p sub 0 times t. Let us work on some examples. So let's have this first example. Consider the ellipsoid x squared plus 4y squared plus z squared is equal to 18. Find an equation of the tangent plane to the ellipsoid at the given point 1, 2, 1. So let's recall the formula to be used. So for finding equation of the plane or tangent plane to the ellipsoid, so we have here the following formula. So again, we have here partial derivative of the given function with respect to x evaluated at p sub 0 multiplied by quantity x minus x sub 0 plus we have here partial derivative of the given function with respect to y evaluated at p sub 0 multiplied by y minus y sub 0 plus the partial derivative of the given function with respect to z evaluated at p sub 0 multiplied by z minus z sub 0 equals 0. So with that, we're going to find the function. So in this problem, the given function is the surface, which has the equation of an ellipsoid. We have it as x squared plus 4y squared plus z squared minus 18. Or we can also get rid of this constant because when we get the partial derivative, this will be 0. So we can include or you can exclude it. And then we have the given point 1 to 1. So we have the given point 1 to 1. So this will be your x sub 0, y sub 0, and z sub 0. So let's now find the gradient of this function. Then we have now to take the partial derivative of the given function with respect to x, then with respect to y, then with respect to z. So let's start with x squared with respect to x, so that will be 2x. So let us form the bracket, angle bracket form. So we have here the components of the gradient of the given function. So starting with partial derivative of the given function with respect to x, so that is 2x, this will be 0, 0, and then 18 is 0 because y, z, and 18 are all constants. Then let's now define the partial derivative of the given function with respect to y. So this will now be the second component for our gradient f. So we have it as, so x and z will be considered as constant. So here 0, then this is 8y. So we write that, then 0, then 0 because both are constants. And the partial derivative of the given function with respect to z, so being the third component now for the gradient f. So x and y are considered as constants, so this will be 0, then this will be 2z. Then of course this will be 0 also. So with that, we can now define the normal, or this is now the value of the gradient f evaluated at the given point 1 to 1. So with that, the normal vector or gradient f will be, you have 2 times 1 and the value of x or x sub 0 is 1. So we have here 2, then 8 times y equals 2. So 8 times 2 is 16. Then 2 times 1 is 2. So we have this as the normal vector which is parallel to the gradient f, and it is perpendicular to the plane. So with that, we now have to find the equation of the tangent plane to the ellipsoid. So with this formula that we have here, so f sub x sub x, rather f sub x p sub 0, f sub y p sub 0, and f sub z p sub 0 are the values that we get from the normal vector or gradient f. So we have here 2, 16, and 2. So with that, we now have this as 2 multiplied by x minus your x sub 0 is the same as the coordinates of your point p sub 0, which is 1. Then you have f sub y evaluated at p sub 0 is 16. Then we have y minus y sub 0 is 2. Then f sub z evaluated p sub 0 is 2 multiplied by z minus 1. So this is your z sub 0 equals 0. So with that, we can now simplify. This is 2x plus 16y. Then we have plus 2z. For the constant term, we have negative 2, negative 32, that's negative 34, negative 36 equals 0. So we can still simplify this resulting equation multiplied by 1/2. So this is now 2x times 1 half is x plus this is 16y times 1 half is 8y plus 2z times 1 half is z. Then negative 36 times 1 half is 18 equals 0. So this is the equation of the tangent plane to the ellipsoid at the given point 1, 2, 1. So in this slide, I have here the answer that is provided. So as you can see right here, the answer or final answer is x plus 8y plus equals 18, which is the same as my answer.